Imagine for a moment, can we ever move faster than light, the fastest entity in the universe? A tantalizing question, isn't it? This is where our journey begins, at the very edge of human understanding, where light, the cosmic speedster, sets the pace. This speed, approximately 186,000 miles per second, is considered a universal constant, an unbreakable cosmic speed limit. But what if we could break it? What if we could go beyond the speed of light? Seemingly impossible, right? However, there are two theories that challenge this cosmic barrier: the warp drive and wormholes. The warp drive, a concept straight out of science fiction, suggests the possibility of bending space to move faster. On the other hand, wormholes propose the idea of shortcuts through space. Speed of light, a limit or just a challenge? Let's delve deeper. In the realm of science fiction, warp drive is a familiar concept. But could it be more than just fiction? Imagine you're at a bustling airport. The distance from your gate to the exit is long, and your luggage is heavy. You spot a moving walkway and step onto it. Suddenly, you're gliding along, covering ground much faster than you could by walking. This is a simple way to imagine the concept of a warp drive. In the grand theater of the cosmos, the stage is space-time, a four-dimensional fabric woven together by the universe itself. Now, what if we could manipulate this fabric, bending and stretching it to our will? That's essentially the idea behind a warp drive. Picture space-time as a flexible sheet. A spaceship sitting on this sheet would create a dimple, a dent caused by its mass. Now, if we could somehow compress the space-time in front of the ship and expand it behind, we'd create a sort of bubble. The ship itself wouldn't move. Instead, it's the space-time around it that's doing the moving. And because space-time itself isn't subject to the cosmic speed limit, the speed of light, it could move the ship faster than light. In theory, a warp drive could allow us to traverse vast interstellar distances in a flash, while neatly sidestepping the pesky laws of physics that prohibit faster than light travel. It's like taking a shortcut through reality itself. But before you start packing for a whirlwind tour of the cosmos, remember that all this is purely theoretical. We don't yet have the technology or the understanding to bend space-time at will. Plus, the energy requirements for such a feat are, quite literally, astronomical. However, the fact that we're even contemplating these concepts is a testament to the power of human imagination and our relentless quest for knowledge. Warp drive, then, might be our ticket to the stars. But it's not the only one. If warp drive is a moving walkway, then think of wormholes as shortcuts. Imagine you are on one side of a vast expanse, say a desert, and you need to get to the other side. A direct path across seems impossible or time-consuming, but what if you could just dig a tunnel straight through beneath the surface and emerge on the other side? That's a wormhole for you in the vast desert of space-time. Wormholes are theoretical bridges or tunnels, shortcuts if you will, through the fabric of space-time. Now, this might sound like something straight out of a sci-fi movie, but the existence of wormholes is actually predicted by Einstein's theory of general relativity. Yes, the same theory that gave us the concept of gravity as a curvature of space-time. Let's simplify this with an analogy. Think of space-time as a piece of paper. Now, if you wanted to travel from one end to the other, you could go in a straight line across the surface. But if we could fold the paper, bringing the 2 points closer together, and then poke a hole through it, we've just created a shortcut, a wormhole. However, before we all start packing our bags for instantaneous interstellar travel, it's important to note that there are some significant challenges. For one, we've never actually observed a wormhole. They remain purely theoretical. Secondly, even if they do exist, they are likely to be extremely unstable. The moment anything tries to pass through, the wormhole could collapse. And there's also the question of size. Theoretical physics suggests that any naturally occurring wormholes would be microscopic, much too small for a spaceship or even a single particle to pass through. But if we can somehow figure out a way to stabilize and enlarge a wormhole, it could potentially allow us to travel vast distances across the universe in the blink of an eye. Wormholes, then, might be our secret passages to the universe, but can we really use them? That's a question that continues to intrigue scientists and space enthusiasts alike. As we push the boundaries of our understanding, who knows what fascinating discoveries await us in the cosmos? The theories are fascinating, but how close are we to making them a reality? As we venture into the world of warp drives and wormholes, we must acknowledge the significant hurdles that stand in our path. Theoretical physics paves the way, but the practical implementation of these concepts is akin to scaling an interstellar Mount Everest. Firstly, let's consider the energy requirements. To warp space-time or to hold open a wormhole, we would need a colossal amount of energy. Think of the energy equivalent to converting the mass of a star like our Sun into pure energy. This is the kind of astronomical power we're talking about, and currently we're light years away from harnessing such capability. Secondly, both warp drives and wormholes require something called exotic matter. This is a type of matter that has yet to be identified or even proven to exist. Exotic matter is believed to possess negative energy density and negative pressure, properties that defy our current understanding of physics. Without this exotic matter, our dreams of warp drives and wormholes may remain just that, dreams. Furthermore, the potential dangers of faster-than-light travel cannot be overlooked. What happens when a spacecraft moving at warp speed collides with a speck of cosmic dust? Or what if a wormhole collapses while a ship is passing through it? These are just some of the terrifying possibilities that underline the perilous nature of our quest. Despite these daunting challenges, we must remember that human progress has always been fueled by our desire to overcome the seemingly impossible. A century ago, the idea of humans walking on the moon seemed far-fetched, yet we made it a reality. So, while warp drives and wormholes may sound like the stuff of science fiction today, who's to say what tomorrow may bring? Our understanding of the universe is constantly evolving, and with it, our technological capabilities. The journey to faster-than-light travel is not an easy one, but who knows what the future holds? After all, the universe is full of surprises.